What should be the target of this session is that after the session you should have a pretty much good knowledge, or at least in a general level knowledge, what the new Synapse offering is and why you should be interested into that. If you want to see more and try out more, the offering is now publicly available, so we are not going through anything that is not reachable from the public tenant in here. Probably something that has a, I would say, limited documentation available, but very kind of clearly everything is possible, and nothing like secret is being shown. Okay, so what is the Azure Synapse? Microsoft says that it's an Azure Synapse is an Azure SQL data warehouse evolved. That's how the marketing slide draws the picture, but I personally a bit disagree, because we have a big technical shift or architectural shift in the behind the scenes. So I would say that's why Microsoft says that it's a SQL data warehouse evolved is because many customers are running the SQL DB and they want to see kind of that path going on. Of course, you can migrate and you can run your same workloads on the Synapse platform, but it's not just a new version of the old, because there is a kind of big architectural or technical change behind the scenes, and then that's something we are going to see. So I even have the reference for where I picked up the slide. So the same image or the next image is pretty much the same as Oskari showed. So if you ask from Microsoft how the modern data warehouse is built and what components it contains, if you ask them like 2 months ago or 3 months ago, this was the image that they would draw on the wall. So we have data that is coming from various sources. We have an ETL layer. We have data lake or an unstructured data processing layer, and then we have a SQL DB or the kind of standard database relational world at the end, and of course something that we need to visualize the data for the actual end users. How Synapse or how Microsoft now puts Synapse into the picture is that we are replacing all the upper parts of the architecture. So now it's same source data, same storage, same visualization, but we have one offering in the middle. That's something that they are targeting to. Now the offering is in preview, and we have just taken like a first few steps towards that target. But anyway, that's the vision, and actually the vision has evolved during the few months already quite much. So if we think Microsoft slides like half a year ago or a few months ago, when they were talking about Synapse offering, the SQL part was actually had 2 different spots. So there was what they called a provisioned SQL, meaning the SQL data warehouse, and then the on-demand SQL, which we will look in detail shortly. And now already in this few months, they have kind of merged those offerings together, at least on the PowerPoint slide. And I see that coming when going forward. So instead of having kind of separate services and components, what Azure Synapse is a unified experience for managing all of your data in a single pane of glass. So no, you should not kind of need to know what are the individual components behind the scenes. You are using one service which will handle everything from the ELT, ETL part up to the kind of modeling the relational part. And it's kind of, even though some things are not public yet, it's kind of funny to see the message being evolving during the time. So this is kind of first noticed how the Synapse has already evolved during few months. One important thing when comparing to other similar type of offerings, mainly the Snowflake, because that's what you are always comparing against, is that in Synapse offering, the openness of the data and the data storage layer is the key thing. So it doesn't have a proprietary storage layer. So everything is stored in a data lake storage, meaning that if you are not willing to use or don't want to use the built-in Spark environment, for example, you can spin up a Databricks cluster and connect to the same storage easily. And while other offerings or other products have their own storage layer, and then you are back to the business where you need to export and import things, or you need to have a connector and query against those kind of different endpoints rather than connecting directly to the storage. Good. Kind of new way to how you should see what type of services there are available in the Azure Synapse offering is that they will it is a combination or union of four main components. First of all, the Synapse SQL. Synapse SQL is offered in two different flavors. Either you pay by hour for the provisioned or fixed resources you have. So then if you've used SQL Data Warehouse in Azure, that's pretty much the same thing. So you will spin up a cluster, define how big it is, and then you will pay for the reserved resources you have. Or you can, as we will see shortly, you can use what's called an on-demand SQL, and that's a SQL Server compatible endpoint, which you can connect with Management Studio or whatever tool you are used to. But instead of running on a provisioned server cluster, it's actually running in a shared environment where you just invoke a query and it will find available resources and then run your query, and you will pay only for the amount of data you have scanned. So not instead of kind of minute or second or hourly based, you are paying by the terabytes scanned, and then it kind of makes the game a bit different, because then what you are expecting is that you get a huge cluster to run your query, and you are only kind of that plays a role. So no longer you need to define a cluster size, because that's been defined for you, and Microsoft's interest also is to provide you as big cluster as available, as then kind of they are more quickly free to offer or serve other customers or their queries also. Okay, then we have Apache Spark environment. We will see what flavor this is. Microsoft is not officially saying anything what flavor of the Spark environment they are offering. It's based on the open source components, so definitely it's not the Databricks version. Currently, a week ago, Oskari presented the Delta Lake offerings and also the new partitioning methods in the like the Z vector on the Databricks cluster, and those are not available in the Synapse Spark. There is a Delta Lake, but that's the Delta Lake file format, and that's working on the Spark, but it's the open source version. So until the Spark 3.0 comes out, there is a variation or difference between the file formats. So it's not fully compatible with the Databricks implementation of the Delta Lake. But Spark 3.0, if I remember correctly, comes within a few months or so. So this is like a intermediate step. But anyhow, Databricks as a company is, as Oskari said a week ago, is inventing new things, and they are not releasing them in an open source ecosystem as they invent them immediately, and that means that the Apache Spark on the Synapse platform is lagging some functionality when comparing to Databricks, and that's I would say that's perfectly okay, because there are two different offerings. One is the kind of top of the top or best of the best offering, and the other one targets the kind of unified kind of one single common experience type of thing. And then at the end, as the storage layer is open, both of the clusters can still communicate with the same data. So I would not see that as a huge problem. Of course, it would be fancy if Databricks would offer everything in an open source community immediately, but that would make their making money more difficult for them. So that's understandable. Okay, then Synapse pipelines. That's actually Azure Data Factory. I'm not even saying evolved, because that's Azure Data Factory. How Microsoft pronounced the thing is that they are sharing the same capabilities. The concrete thing is that they are also sharing the same code. So it's basically exactly same service. Behind the scenes, only difference is that on Azure Data Factory, when you need a Spark cluster, you're running that in an Azure Databricks Spark cluster, and in here you're running that on the Synapse Spark cluster. So technically the Spark execution environment behind the scenes is a different one. But anyway, they are not using any of those Databricks functionalities. So doesn't make kind of any difference. And then the Synapse Studio is the web user interface we will be seeing shortly. Regarding the functionality, they have a roadmap for functionality. As said, we are in a very early phases of this. So some of them are private preview, some of them are public preview. This slide is from the Build conference last week and publicly available if you search for it. So nothing like hidden or something. You can take a screenshot and share. That's available. But what you should see is that they are investing heavily for those things, and what we see today is something like a beginning of the journey. Good. Okay, then as a final step, this is like a one thing where Microsoft will have a variation when comparing to other vendors, and that's that as the storage layer is based on the data lake Gen 2, always you are saving more and more data in there. The question always comes at how fast you can process the data on top of that layer, and there are actually some very interesting things coming, and the one specifically is the kind of specifically designed accelerator for reading JSON CSV data so the raw data you are storing in the Delta Lake or data lake environment. So if you kind of currently use whatever Spark cluster or whatever infrastructure to read your CSVs, you are reaching something like hundreds or tens of megabytes per second per node speed. So you can of course grow the cluster and get more size. But when using kind of dedicated hardware specifically designed for reading certain file types, you can reach kind of huge amount or read huge amount of more data per second, and that's something that is arriving for the storage layer. And then the Synapse will start implementing that immediately. And of course, whenever Databricks and others get to that boat, or WAN also will benefit from that also. But if we today compare the speeds between different systems, some parts of the Synapse are already using this, so that's why it's so fast to read files. Okay, then for the actual environment. So how do you provision, or what the Synapse environment now, or the new Synapse is it begins with the Synapse workspace. So from the Azure portal, you will create a new resource type and search for the Synapse workspace. Then that's something you will first provision. During that provision, you need to define a first storage, which will be like a kind of default storage for the environment. But you can add more storage accounts and more storage more storage offerings later on, no matter whether it's a Data Lake Gen 1 or Data Lake Gen 2 or even a standard blob storage. But during the provision, you need to define a one Data Lake Gen 2 compatible storage account, and that's being used as the kind of main storage account inside a Synapse workspace. Then you can define later on the SQL pools, and you will have one SQL pool, the on-demand SQL pool, always created. I'm not even sure if I can delete this one. I hope not. No. So that's kind of there as a placeholder for your query executions, and then you can define as many provisioned fixed SQL pools as you want, and these are kind of the good old SQL data warehouse pools. So the pricing is similar today. The technology is similar. So not probably tomorrow, but today they are the SQL data warehouse pools, which you can kind of provision or create inside this experience. Then you can also create Spark pools, and you can also create these from the Synapse workspace. And when creating the Spark pool, you define how many nodes that will have what are the node size, meaning the from few different options, and then you can define how many minutes it will stay awake after your last execution. Currently, the environment doesn't have any setting for you to pause the actual cluster, so it has only the auto pause functionality. So if you put in here 10 hours, it will be 10 hours until it sleeps, and then you should be able to choose what Spark version you want to use, but technically today you only have one option. Probably when the 3.0 comes out, you probably have that also in addition to 2.4. And as Microsoft is heavily pushing now the kind of .NET Spark edition, it also has the capability to run .NET applications in the Spark cluster. So not many vendors or offerings have this functionality today, but here it, of course, as it's a cluster type built by Microsoft, you have that option. Okay, then you define the firewalls and the endpoints and vice versa, and then the interesting part starts when you launch the Synapse Studio. So I should have it open here, and I'm now running my select one for the Spark cluster, so that I don't get the auto pause functionality. And when you go to when you open the Synapse workspace, this is where you will land on. So kind of the home screen of the Synapse workspace. On the left-hand side, you have different areas within the system, and or kind of all the things and offerings we had are tied behind these sections. And if we first go to the orchestrate section, you can quite soon see that what's inside an orchestration section where you can build things called pipelines. And when you open a pipeline, you can quite soon see that basically these are Azure Data Factory pipelines. One addition or one difference is that here for the as a first section, it has a Synapse possibility to run notebooks and Spark jobs from the Synapse environment. I think this is not available in the Azure Data Factory size, but everything else exactly as in the ADF. So all the components you're familiar are available here as they share the same code behind the scenes. Why would you use ADF in the Synapse workspace? Well, you have pre-configured connections for all the storage you have defined. So that would be kind of, I would say, one thing which could help you during your time. So you need only define one connection string, and it will be available in different parts of the application. That's pretty much, I would say, the kind of gain you would currently get, because other than that, as said, it's the same old ADF as previously. One basic thing missing, even though it has the publish all functional, it doesn't have the save button, neither it doesn't have the integration to version controlling as of today. So in this preview phase we only place we can save our code is to publish them, and then that's our kind of not version control, but the storage for all the scripts. Okay, so but this is like old good stuff. No need to spend time there. If we go to the data section, this one, and start from the linked services. Here we have all the storage accounts we have linked to this Synapse workspace. I can add new or link new resources, and they will be available for browsing over here. They are shared, or kind of the registry of linked entities is shared between users. So if I log in with the different user, I also see the same accounts available here. But the authentication is based on my own identity. So it's a pass-through authentication against the source. I have two different, or in one storage account, I have two different. What's the name? Not share, but how do you call them? Oh, I forgot the name. Help me. What inside a storage account you create multiple, not share, but
containers or
containers.
files.
That's the correct word. So you create multiple containers. I have two containers, and as said, one of the container needs to be kind of the default one. It says here as a primary container. So in addition to that, I have created one container, and you need to give permission to that Synapse managed identity to read all the metadata and other from the container. But other than that, all the user access is still based kind of as a pass through. So I don't see any folders. I don't have a privilege to view. So end user would come here and search for its data. You could of course always use the storage explorer, but I'm looking for my data. I will go for the Microsoft Open Data. I will select the Parquet version. I will take the population folder, and I will find some data. Then how I would like to see inside that file. So I can second mouse click, take a select top 100, and it will give me a command which I can run. And when I'm running that, I can easily kind of look inside the file. It works against the it will work against the CSV, JSON, and Parquet. Today it works against the CSV and Parquet. So JSON is something that is just around the corner to come available. But today it works for those two different file types. And here we can already see the kind of how it connects to the source. So basically, Microsoft had all the tools from the T-SQL language, and they need to define how can we build up a connector in here, and the open rosette function is a good candidate. So that's what they used. Good. And then if we have other data sources, so for example the Cosmos DB defined as a source, I can also browse through that. So not only the kind of SQL databases and storage accounts, but also in future other type of data storages, meaning NoSQL type of sources like in the first phase Cosmos DB. And you can even select from these sources and then as we see we'll see, you can even create views for it, and then you actually have a like a T-SQL endpoint or SQL Server compatible endpoint where you query some non-relational data or such. Okay, if we go or start from the actual SQL story, the first I will first you can view all the entities you have. You can actually view also all the Spark entities you have. So if you have databases available in Spark, you can view them here, and then as said, you can either start a new notebook, or you can even start a new SQL script to query from those sources. We will shortly see. So kind of as a first step, end user will come here, browse the raw sources, or browse the actual linked databases and try to find his or her data from there. But if we go to the develop section, this is, I would say, one of the biggest things I would like Microsoft to enhance very shortly, is that if you go to the develop section, it's the place where you save all your SQL scripts or all your notebooks. And currently, this one, first of all, doesn't have any security boundaries, so everyone can see all the scripts you have here. And secondly, it doesn't have any folder structure or so. So if you compare this to Databricks, for example, you can have your own personal folder and you can have permissions inside folders. That's kind of something I would like to have here also. But currently, one workspace has one set of files, and they are all listed here. So you need to come up with some kind of own internal structure how to organize them. Then when you start developing, you can create databases. So even when you don't have a kind of cluster running, you can come here and create a database, and then that database is available, or should be available, is available on the list of databases. And remember that everything is reachable with the Management Studio or whatever tool you have been using to reach SQL Server. So the endpoint, even though I'm currently using that as in a browser, is reachable with the kind of all the SQL tools you have. You can create logins, you can create users, SQL logins, and everything you are familiar with within the SQL environment works here, even with the on-demand cluster. Okay, if you the kind of everyone wants to run, what's the version number? If you run the version, it actually tells you that it's the Azure SQL. So the version number is exactly same as in the Azure SQL, and that's how kind of for example, the Management Studio looks for the thing. So if you connect with the Management Studio, it just thinks that, okay, it's another Azure SQL endpoint for me. Okay, then you can create connections to different sources or credentials to different sources. You can either create shared access signatures if your provider uses that, or you can create what's called pass-through identification. So here, when I have created the Vesku database, what I have done after that is that I have created two different credentials with the user identity pass-through keyword, and after that, whenever I run queries, they are actually, and I run queries from the storage layer, they're actually using my own identity. This has one kind of caveat, is that if you use this pass-through authenticity, you cannot use SQL authentication when connecting to the instance, or you can use, but of course all the views and external tables you have created do not work because you cannot pass through the SQL authentication against the source. So you need to pick it up. So either you need to create, for example, two different credentials and then create some entities with the shared access credential and some with the pass-through, or you need to leave the SQL authentication away from the picture. So that's kind of something that will not be fixed, because I don't know how you would fix that system, because SQL authentication doesn't exist on the storage layer. Okay, when we start actually implementing our queries, we already saw that you can run the open rowset command against the storage. And now when I have a credential, pass-through credential against the demo data share, I can run a query that selects from the source. Currently, this is something that probably will change, but as said earlier, the Microsoft had kind of T-SQL syntax in their hand, and they needed to, with those building blocks, they needed to start building a new offering. And what it meant is that, for example, the open rowset needs certain parameters or certain hierarchy, and then finally, and we don't have JSON as currently as a data type is not natively supported on the SQL Server, because you can cast as a JSON, but it's always done in a dynamic format. So if you store JSON in a database, you are always storing that within the nvarchar column or varchar column, and that's why, for example, we cannot read format equals JSON, because that's not natively currently supported. Probably the next version of SQL Server will solve this. But now I'm casting that to varchar, and I can read the JSON or the JSON documents from the storage. I use the star, so it actually reads through all the files that I have in the demo data open data JSON box folder structure. So here we should have like quite many files, and it went through all of those. Okay, if we want to use the actual JSON, we can, similarly as in SQL Server, we can read JSON values from it. So then, and we, as said, we have all the capabilities we have in the SQL. So I'm doing some kind of aggregation and I'm doing group bys, and I'm writing the query exactly same as I would do in a standard SQL server, only that my table source is the open rowset command, which you technically could have in the SQL server also, but not against the data lake. And then this query does the aggregation and should pop up the results back to the screen. Then Oskari mentioned a week ago regarding those kind of partitioning and having designing a folder structure that could kind of benefit you while reading the source, meaning that you would not need to read all the files from the source. Now I will try if I can press Control minus. Yes. So here I'm reading through the same source but partitioned, and the partitioned folder structure has few levels, and I'm mapping those levels as a country and type. So first star equals country, and the second star equals type. So you can map the folder structure to your columns, and then you can define where clause also against those kind of same parts, meaning that now I'm only browsing through the single portion of the partitioned structure. So I had Finland, Norway, and Sweden. I only went through the Finland and then through this box section in there. So that works. And then of course you could use the kind of all the combinations that only aggregate. So here I'm selecting the first 10 to explain what the structure is, and then I'm aggregating and also using some where statements, and where statement can either be part of the folder structure, or it can be, as in here, part of the actual document. So I'm selecting a where statement, again something inside a JSON object. This is exactly similar as you can do in the SQL Server if you store the data in the database. So, but as described, you can run this now against the CSV files in the storage. Okay, and then make it more and more complex using the same file path components, doing a filtering, doing a group by, whatever you kind of have in your mind. You can the kind of query language is all there. So it's not just a subset of the T-SQL, it's all the T-SQL power and all the functionalities you are used. Okay, this after you have created a complex statement or something, it's not the one that end user would like to use. So basically, quite often you would like to create a view out of it. So as in standard SQL Server, let's drop the view if it exists. You can create view from whatever select statement you have. So I have this exactly same statement as in previously, and I'm creating that as a view. I need to create in a user database. So master is no go. You need to create a database and store it in the user database. But after creating this, I have a view in my database which I can easily query, no matter what the tool is, Excel or Power BI or whatever tool that can read views from the SQL Server. And then I can even of course create views. That was the JSON value. I can create views against the different file formats, meaning, for example, the Parquet file format. Currently, this on-demand SQL does not support the Delta Lake format. So even though Microsoft says that Delta Lake is supported, or the open source Delta Lake is supported, it's only supported in the Spark cluster, not on the on-demand SQL, but that was part of the announced roadmap things. So it will be there, but currently it's not. And then when we kind of end user comes to the database and selects, he writes a very simple query where year is something and month is something, and gets the output from the system, and doesn't know that we are actually using columns from the file path, and we are doing some other things behind the scenes. So that's why kind of it's very compatible with all the old applications we have, because you have a SQL endpoint and you can query as you have always done. Okay. Then regarding the kind of speed from this infrastructure, this should have quite many rows. So we have something like 230 million rows on the system, and I'm not cheating to just create a count. If I do some groupings and some summing and some average, I'm forcing kind of multiple columns to be read from the underlying storage, and it still comes pretty fast. So that's where kind of that hardware accelerated reader actually comes to the place when you are using or when you are querying the storage. So that's kind of fancy thing. And when we look for this file system, how much data there was actually was. So if we go here to the Parquet and Taxi, and then we have multiple years, and inside every year we have quite many files. This is actually quite small one, but some months had like 900 megabytes files or something. But in total, the file kind of scan size we went through was something like 10 gigabytes or something. So and still you need to remember that it's the on-demand cluster. So I don't have a provisioned cluster running somewhere. It's the on-demand version I'm always querying against. Okay, then if you are SQL person who wants to do a lot of things in the T-SQL whenever possible, you can the on-demand SQL plus now the provisioned version also supports the Parquet file format, and you can create first of all external data sources and file types. That's pretty much same as always, and then you can create what's called an external table. Let's drop if that exists, because I think it's there. Yes, and you can create what's called an external table, and that actually creates a new files, and you need to define what file format they are using. So and then you are creating that from a select statement. So and in this select statement you can transform the data or do whatever you want, because basically this is again T-SQL compatible select statement. But the output don't have to come to the screen. It can come to the external file format, and now location already exists. So let's go here and look from not from the demo data here, and it was, if I remember correctly, warehouse Adventure Works, not this one. Let's go some steps back. It's on the demo data raw work. So that's the folder. So Synapse raw work demo, and here. So this folder already exists, and that's why it gave me the error. I will delete that. So create as a table currently requires that you cannot have the folder available. But when you have a kind of empty destination, you can run the it still exists. So now every one of you were laughing there that okay, the guy went to the incorrect folder. Let's see, and now together we can manage this. So Synapse is the share. From there, we should have a raw work demo and this folder. So I had the same folder in the kind of additional share or the kind of demo data share, but actually I was inside the demo using this primary storage. So I will run this one more time, and hopefully now it's running, and it should be visible over here now. And here we are using or kind of creating those Parquet files as a destination. So create as a table works, and internal tables do not work. So in the on-demand SQL, only place where you can save data is actually on the Azure storage. So you always need to create things as an external table. And as said, Delta Lake file format is not supported, so you can only create new stuff currently, and modifications are not allowed against that target. Difference between external tables and views is that external tables, both of them, first of all, reference to data that is in the data lake, but external table, your credentials needs to be saved into the system. So pass-through is not available for the external table because it kind of system handles that. And then the view is something you on the runtime you find the context of the execution. So views can have that pass-through authentication. But doing this, we can connect to the or create new entities, meaning new external tables, and use them on the database. And again, this one shows if we select from sys.tables as we've always done in the SQL Server, we can see that it's just a table there. So if you connect with Management Studio, you can see one table and you can select from there. Inserts and updates do not work currently as the Delta Lake file format is not supported, but other than that, it's just the table. Okay, then we have a thing called Hive catalog tables, meaning that if we go to the data view, we can see that in addition to my on-demand database, I can actually see Spark databases also. And if I open a notebook I have prepared and then try that my cluster is still running, yes, perfect. And use the Spark to read data and create entities in the Hive catalog. I can, for example, here read some data from the source, and then write this as a new table in the Vesku Spark database. And if I do this, it's available for me on the, where is it? Hive catalog tables here, and if I change to the Vesku Spark database and then go back to this one when it's ready, it's now ready. Already exists. I have not. I will do like this. Oscar, you can see that I have those dropped statements over here. So it's just that I have not run them, but I have prepared the demo so that it should not have any issues. But I had the error was that I have the table already on the system. I will create that as a number 2, and now when it's ready, succeeded. This is the name of the name of the table, it's also reachable from the SQL side. So I should be now in the same select top 10 star from here and running that, and it should come up with the same structure. So you can create entities in the Spark and save them in the Spark database, and they are immediately available also from the SQL side. So think that you have a data scientist or data engineer who uses Spark to do modifications. No longer you need to design how can we write this to SQL for end users to be able to consume that. Of course, someone would say that of course you can connect to Spark SQL on your own, but it kind of most of the client tools, they have a native capability to connect to SQL Server, but they don't have a native connector to the Spark SQL. And then if you can enable connections to the SQL Server, then you kind of open whole lot new worlds. And now whatever you save into the Spark database, that's immediately available as a separate database on your SQL Server endpoint, so the Synapse SQL endpoint. So now this table was immediately reachable from there, and even though when you create whatever tables or structures, they are views and tables available from the SQL endpoint. Okay, T-SQL endpoint, I mean. And then the kind of next big thing Microsoft was promoting was the C# language on the cluster. So first, let's like a smoke test that we can run this. So and we will just stop the demo if it doesn't. But let's hope the kind of default language in this notebook is a Python, but with %C# I can run the C# engine behind the scenes, and it's running the new interactive .NET. So you can write if kind of console write line. That's the kind of most basic command. You can run that and it just works. So it's been compiled on the runtime. You could do some kind of more complex things, meaning that in C# you have the environment variable available, and from there you can print different properties. So environment has a lot of different properties you can request. So environment.os version, for example. You could run this on the let's put it over here. So console.writeLine, then output this one, and you could run this. So C# has these versions. You can see that it's actually running on the Unix currently, and I have here collected all the different variables or properties available, and then even as a for each all the environment variables that the system exposes. So, and this same code could run in a Windows. So there's kind of nothing Spark specific or something, but I can run this, and I would say that, as I said at the beginning, that I'm not showing any private things, but probably something not documented. This is probably one of those things. So you can write or print out everything from the cluster. And I would say that the kind of few interesting things over here is that first of all we are using the .NET Core 3.1. That was actually available on the provisioning page. It was not before, but it's there, so this is not a secret anymore. But then when I said that they are using their own flavor of the Spark offering, that's not completely truth, because what you can hear or see here is that we are actually using the HTTP version of the Spark cluster. So Hortonworks has been a kind of a partner previously, and that's the thing going forward. So there are kind of quite many references to the HTTP version of the Hadoop cluster behind, or Spark cluster behind the scenes. So that's, I would say, not surprising, but they are not promoting that actively on their marketing slides. One interesting thing is that, of course, when you are building things, you are building them in the Windows. So many of the call stack errors are actually promoting kind of Windows file structure, and that's because this was compiled. The code was compiled. Microsoft has compiled it in the Windows and then put on the Linux or Unix environment. But basically, it's a Hortonworks distribution of the engine, probably heavily modified by Microsoft. That's how it actually looks like from the outside. Okay, then what? Of course, you can read all the kind of good things. So I wrote somewhere or tell someone that it's weird that you can write Spark statements and use LINQ to kind of modify that. It's kind of it's something that has not been able to do before. But if you are coming from the .NET side of things, it's actually kind of an easy way to get to the Spark development, because everything you've learned, you can actually use those same skills, even the LINQ execution engine works, and then use that on this infrastructure. Regarding those last week, if I have it here, if I don't, we will skip it. But sorry, I don't have it. But we were Oskari had a session regarding the architecture in the Spark and how they compare. So what's the kind of difference between Python and a C# as an execution engine? And I actually did, and my browser kind of crashed yesterday, and I did not find that it's not been saved. I wrote the same statement in the C#, and then after that looked for from the kind of Spark environment, that what's the actual how it was implemented behind the scenes, and the architecture is actually pretty same. So kind of the call stack it was similar in Python and the C#. So Oskari had some statements that Microsoft is using newer technology or something, and that's probably true. But at least the kind of, for me, it looked like that how they have integrated on top of the Spark is very similar to the Python, because kind of for the first on the call stack, the four or five first calls from the Scala engine were exactly the same, and then instead of that Py4.js, it went to the .NET libraries, and then of course it was a completely different. But anyway, kind of if you think that is it a faster or slower than something running currently, I would say that the call stack is looking the same. So it doesn't have any additional abstraction layers on top. So the call, how it behaves on the platform, is very similar to Python implementation. Okay, so that's kind of all the things I had. One